Hi, everyone. Thanks for joining today to hear our zED talk on insights into COBOL 6.3. Our presenters today are Zvi Weiss and Ed Steele. Both Zvi and Ed have been in the IT industry for over 3 decades and work closely with Z software such as COBOL. I'm looking forward to learning from their expertise on the subject. And for those of you who are unaware, this session will be part 1 of a 2-part COBOL mini-series that we're doing for zED Talks. The next event next month will actually be on COBOL migration and ABO, presented again by Zvi and Ed. So we expect their presentation today to run about the full 45 minutes. If you have questions, please feel free to put them in the Q&A panel. For the sake of time, we'll most likely wait until the end of the presentation to address those questions. Also be aware that this session is recorded, and I'll send out a link to the recording once it's available. And finally, there will be a poll after the session with a few questions. So if you could please take a minute to answer those, that would help us improve in the future. And with that, I'll pass it off to you guys.
Thank you very much, Brian. This is Ed Steele. I'm a IT specialist with IBM, and I'm joined with my colleague, Zvi Weiss. Today, we're going to talk to you about COBOL 6.3 value-added features. And just to keep everything a little more lively, Zvi and I, we tag team these slides. So we hope not to put you asleep with one of us talking, so we're going to alternate the slides, and hopefully keep things a little more active. So with that, Zvi, you want to take the next one?
Okay, this is Zvi Weiss, and Ed's going to keep me honest. The point here of this foil is that when we talk about COBOL 6, we talk about all the benefits that there are. You shouldn't feel panic at the thought of you got to get there because we're no longer selling COBOL 4.2. The end of marketing for COBOL 4.2 was over a year ago. But the end of service for COBOL 4.2 is going to run through April of 2022. So you have a lot of time to plan your migration, to figure out which programs are going to be the ones that are going to be what I'll call the low-hanging fruit to take advantage of what we're going to try to show you in COBOL 6. And also keep in mind that even after you're using the new compiler, if you have programs that were compiled with the old compiler and are running and a problem develops with the runtime, those will be supported. So I just want to emphasize that in order to take a good advantage of COBOL 6, there should be the planning in how you're going to start moving and taking advantage of these features. Ed?
So IBM is trying to practice what we preach to our customers, and we have built support for continuous delivery model. So you can get the new features as they come out and the enhanced capabilities. As you see in this bullet here, COBOL 6.2 shipped in September of 2017, and we've had quite a few enhancements since then. We're now on 6.3. But for terminology today, we just want to point out, you might hear the term PMR, which is a problem management report at IBM, maybe a trouble ticket kind of a scenario. Then there's the APAR, the Authorized Program Analysis Report. And then there is PTF, Program Temporary Fix. And that would include APARs and fixes, improvements, and some of the new features that we are continuously delivering to our customers. So you can take advantage of those things right away.
Okay, now we're going to talk about some of these features. And I just want to add, if you have COBOL 6.2 and you've been applying the fixes, the PTS that Ed just described, then in all likelihood you are going to be at the COBOL 6.3 level or very, very close to it because of IBM's continuous delivery model. Now, over here we're going to be talking about, this is the list of what we're going to be covering. The compiler options that are going to be added, enhancements to the actual, some of the rules that are used with the COBOL compiler. As you know, the COBOL compiler now has what I call a rules feature, which lets you flag what I'll call stylistic violations of your developers, as well as additional functions that have been added that now become part of the COBOL compiler itself. And you will see as well, and finally we'll mention national data items. This is especially important for people who have international operations, and that we have the full support for the UTF, capabilities. Ed?
So as I mentioned before, we are doing the continuous delivery model, and some of those fixes that Z just talked about. But we do deliver the bug fixes, the performance improvements, and the new features. And you can find all those at this URL here in the middle of the page. So you can see all the fixes right there. You could do a quick Google for COBOL fix list, and you would probably find the document real quick also. But the page contains a complete list of the releases, refreshes, and the fix packs. And this is a little graphic of what you'll see on that page. So you can see they're all sorted by the version of COBOL that you need.
Okay, now let's start talking about some of the compiler options themselves. One of them, the copy load, is essentially for people who, for whatever the reason, choose to have copy memories in ZFS, or they're compiling on the ZOS unit side and have copy members on the MBS side. Copyloc allows you to specify the data set or the ZOS Unix directory so that you have that additional flexibility. A second option is initial. Initial basically is something that users have wanted because typically what often happens is that when you're calling a subroutine repeatedly, you want to have the subroutine have certain values always initialized. Now, until now, the only way to do that is to add to the program ID paragraph the isinitial clause. The isinitial clause will cause your values to be initialized when the subroutine, when the program is called. The people did not want to always have to do that, and they did not want to always have to worry about using dynamic call and cancel statements. And now by specifying as a compiler option initial, it gives you that capability for your called subroutines. Ed?
Okay, and here's another new compiler option. The omit occurs depending on minimum. People wanted to see this actually because they felt that it was easier to read and less confusing. So what this option does, it tells the compiler whether to issue a warning message for any occurs depending on clause that are specified without a minimum or integer 1 in this syntax, the minimum number of occurrences. So X occurs 100 times depending on Y would be the same as X occurs 1 to 100 depending on Y. A little easier to read.
Okay, now, as I mentioned earlier, we have the rules which flag if a developer is violating a standard. Now, one of the rules was no unrest. That is that somebody had a data item that was defined and it wasn't referenced in the procedure division. So of course you can ask, well, why in heaven's name is it defined? And that's what management might ask also. So unref would tell you, oh, you're using something that's not referenced. The problem was that in some cases the reason it wasn't referenced was because it was part of a copybook. You have this utility copybook that has many, many different fields in it, and not every field is necessarily going to be referenced in every single program. So, and yet it was being flagged as, oh, you're violating the rule because you have something defined that's not being referenced. So the unref has two options. One is unref all says, okay, if something is defined as a data item and you don't reference it, flag it. But unref source says, only flag it if you defined it in the procedure division, in the data division. If you defined it in the data division, then you should be using it. But if it's in the copybook, we're not holding it to that standard, because the copybook is the utility copybook that has many different fields defined, and there's no reason to flag a user not taking advantage of that particular data item in his or her procedure division. So no unrest source gives a much finer way of applying the rule, and also probably makes a lot of people's lives a lot easier. Ed?
Okay, so another compiler option here is the rules in the no even pack. So the bottom line here is that users don't have control over whether a KIX or DB2 translator, so error messages are not generated for names that start with DFH, DSN, EYU, or SQL if you use the no even pack. The default's even pack, so specifying no even pack causes the compiler to issue these messages. So in that case, you got, like the other one that Z just talked about, you've got a cleaner listing. Then the next there is the DS name and no DS name, and they're added to the test and the no test separate option. And it controls whether the sysdebug data set name is used at compile time, and will that be stored in the object program or not. So some users want the DS name in the executable, but most users don't. And as this bullet states at the bottom, you can't please everyone with a single setting. So this is for the files that we're using when you're using a debug tool like the IBM debug tool.
Now we have, this is an example of simply making your program style easier to read. In the past, when you use an 88 level value for a variable, you would have to define both sides, if you will, of the condition. So if you look at the example here, you have an 88 level of done and an 88 level of not done. And what you would do is you'd say, well, if it's not done, set not done to true. And if it was done, you say done to true. And that can be, it works, but it's, how should I put it? Stylistically, it's not so clean, and it can actually look a little bit confusing when you say set not done to true. Okay? I mean, yes, that is factually accurate. It is not done. But saying not done to true can certainly, at least at first glance, look confusing. As a result, IBM changed that and gave you another option, and you've got to go back. It's your turn.
Yep, sorry.
Forward one.
Okay, I didn't know if you were finished. I'm sorry, I apologize.
Yeah, you're all set. You now say the alternatives.
Yeah, so, you know, as V said, it wasn't very clean. So now we have set to false statement and when set to false clause, and you can use those with each other. So you see here the 88 level done value Y. When set to false, it's no. And then it reads a little nicer when you're working with it. Set done to false and perform until done, and then set done to true. So it's a little cleaner, easier to understand. We hope we don't get double negatives in there, right?
Now we start talking about the intrinsic functions. I mentioned earlier national data items. National data items, because of how they're defined, and because that it's actually defined beyond IBM, this is a standard that is beyond IBM standard. So what you have is you actually have data items that have lengths associated with them and have to be manipulated in various ways. So what IBM has done is updated the ability to handle national data items with these various intrinsic functions. And because national data actually have pairs of bytes for these characters, so therefore that's why it now mentions over here that you had reverse, but it wasn't surrogate pair aware. Now you have national data items, and you also have surrogate pair aware, and of course, because this involves the actual execution, not just the compilation, so you'll notice that in order to take advantage of this, you have to update the runtime as well, which includes updating the language environment in which all these programs are executed. Ed?
So here's some examples of the new intrinsic functions, and we'll explain most of these in later charts. So I'll give you a chance to look at some of these: bit to char, hex to char, the absolute value of a numeric item, byte length, exponentiation. So we'll talk about some of these things as we go.
So here's an example, bit of and hex of. Okay, somebody has defined a value, a character value, and for whatever reason it's necessary to know what the hex representation is, or what the bit representation is. Using these functions, you can see it right away. Without these functions, you have to go through a rather elaborate process to do the conversion. Similarly, you have the arithmetic functions of exponentiation and pi, which again allow you to get values that are usable. I won't say that they're exact, especially in the case of pi, but you will get values that are usable without having to do a special library call, because now you have these functions built into your language. Again, and finally you have trim, where you can clean off spaces. A lot of times you get a data item, it has spaces in it. You don't need those spaces. You can use trim to remove those spaces and have just the non-space characters. Again, in order to use it, because this involves the runtime as well, you should note that you have to apply PTFs to the runtime, in this case, that's language environment, where these programs will be executed.
And here is an example of what Z was just talking about. So we have this 77 level my data, pick X6, value hi mom, and you would issue the statement display hex of with the function hex of and passing the field my data. Therefore, your output would show the hex value here that's listed at the bottom.
Now, what happens if you didn't have hex of and you had to find the hex value? So this is an example of what you would have to do to, assuming you didn't have a library function somewhere, what you'd have to do to convert a character to a hex. And notice it says, when it's this value, move this. When it's this value, move this. When it's this value, move this. Going all the way through in order to do that. Most people, I don't think, would want to do that, and the hex of provides a very clean and easy way to give you the hex characters when you need them. Ed?
And as previously, here's an example of the bit of. So it's the same thing as the hex of, only the output down here is hi mom in binary. That's a long string, huh?
Now, some other intrinsic functions, bit to char or hex to char. You have a bit string, you have a hex string, and you'd like to see the character representations. So just like you saw earlier, that you could take the hex representation of the character, you can now take the character representation of the hex. Similarly, you now have functions, and so you don't have to, which were actually part of the COBOL standard, the absolute value, the length in bytes as opposed to characters, exponentiation, numval applied to floating point. As you'll see, numval is a way of processing data that's coming in, which is numeric, but it's not strictly numeric. It has spaces in it. It might have a $ in it. It might have other signs in it, but you'd like to convert it to a numeric string. So you'll see that you have numval, and you'll see also test numval. And again, because these are functions that are executed during the actual runtime, so therefore in order for this to work, there are various PTS that will have to be applied to language environment, which is the runtime environment for these COBOL programs. Ed.
You know, some of these features we're talking about, use case might be when you're doing OCR processing, optical to character recognition. So you might be scanning say a check, and you might have a signed CR for credit or DB for debit on the end. So you're scanning that in. It might be good to, you know, convert that to a value that can be used for processing. And here is an example of the hex to char. So we're showing the hex value here in working storage. And then down below, those characters are converted, or the hex is converted to character. So you see here 12 space 3 apple. Seems I'm getting a little background noise or echo on the line.
Okay, now test numval. What happened is these are added because when people used numval and they ended up getting invalid data. That is, the example that Ed gave was where something was scanned. But in addition to what was expected as a result of the scan, there was something else. And because there was something else, the numval fails. And when it fails, you get an event. It's not like it just fails and the program keeps on going. The program dies. So therefore, test numval was added to try to verify the data, and in addition, numval C was added in some where the character that was input was one that I should say is not acceptable, but in some sense might be expected. So numval C could handle that and still give you the desired result. Numval F is where and test numval F, as you saw earlier, there was a function numval F for floating point. Test numval F, there make sure that numval F will not die as a result. And that's what it's talking about, avoid advent for bad input. And you can see there's a fuller discussion in the Knowledge Center for this. Ed?
Okay, so thanks, V. There's an example. And as the top bullet says, test numval function verifies that the content of argument 1, in this case here, in the compute statement, conforms to the spec for argument 1 of the numval function. So you can see as we do the compute and the display here, we have an error in abend, and it gives the reasons. So as V was talking about, if it is not correct and not handled, you'll see the abend at runtime.
Now, what test numval does for you is it avoids the abend. In other words, over here again, we're doing the same compute we had before, but before we actually do the numval itself, we say, do the test on this value B. If the return code is 0, which means that the argument fed to numval will be accepted, then compute the numval. In this case, process that character string. If, in fact, however, the string does not meet the specification for numval, then instead of appending, simply display and say that the particular string passed is invalid, and keep on, and the program continues. So in this case over here, we have the $, the blanks, the numeric, the CR, and more blanks. So what happens is that this numval cannot accept this, and so it will come back and say argument B was invalid for numval. Okay. Ed?
Okay, so here it is. Test numVal C function verifies the content of argument 1 and makes sure that argument 1 conforms to the specs of the numVal C function. And as I talked about earlier, a good use case here might be OCR processing. I've got a check or a statement, and I've got a CR here in the sign for a credit. So test numVal C would strip off that sign and then verify that the rest of the argument conforms to the specification. And this is how it might be used in this code.
Now, what happened over here, this is the result of what you saw earlier. Argument B was invalid because for numVal, it doesn't accept the $ and the CR and everything else. But for numVal C, it is valid. So therefore, you do the test numVal first. You avoid the append because you say, okay, this cannot be processed by numVal. You then do a test numVal C. It says this is okay for numVal C, and it gets processed. Now, when you have a compiler option, when you are doing this kind of processing, do you want to split off the sign? If you recall earlier, this string included the value CR. Now, CR in accounting terms is considered a minus, as opposed to a debit, which is considered a plus. So when you first run numVal C, it combines the CR with the last character, which was a 7. Well, a minus sign is a D, and the 7 is actually 0D, and the 7 is 07. When you combine them together, you get D7, and D7 is the letter P, which is how come when you see the output, you see this numeric string with the letter P at the end. But if I say this sign sep, which means separate and display the sign, so then the CR is not combined with the last digit. The last digit remains 07. The sign remains 0D, which is a minus sign, and therefore you see at the front now of the string the minus sign, and you see the last character in the numeric string is the number 7. So as I pointed out, this could be an excellent example if you have OCR data coming in, if you have scanned data coming in, to be able to process it in a very clean fashion. Ed?
And if you get out your yellow cards from your COBOL days, you can see all those characters inside the yellow card. So here's another new intrinsic function. This one was new January 2020. It's the UUID4 intrinsic function. And this will generate a 36-character alphanumeric string that is a version 4 universally unique identifier. So this is kind of cool. Maybe you've got a program and you're spinning through the code and it's creating new rows in a DB2 table. So this is going to create you a new universal unique identifier.
And here's an example of just that. Okay, where you're doing the insert. You've used, as you saw in the previous foil, you've used the UUID function to create the identifier, and now you're actually going to be able to insert it. It becomes sometimes it's hard for people to identify a key. For whatever the reason, that they have data, and there's nothing in the data that is truly unique in and of itself. Yes, for a given entry, if I have the person and and I won't say social security number, but the person and their age and their birth date, and I can have a lot of pieces of data which together might be unique, but I don't have a single unique key. The UUID lets you define a unique key without having to worry about how am I going to guarantee that my entry is unique. Ed?
Okay. Now this slide talks about new compiler options again. So V's previous slide was, you know, a new statement, but now this is compiler option. So you can use define at compile time, which is actually a conditional compilation, and that can be in the source code. Then there's init check to find uninitialized data items, and Z talked about that a little bit before. Inline to control the optimizer, whether you want to inline some procedures in your COBOL program. You may have some error handling routines or some functions that could get copied over and over and over, and here you could exclude those or keep them in. Then there's num check to make sure you have valid data that is numeric, and then parm check to ensure that parameters that you're passing are also valid and meet specifications. And those last two you can use very well when you're migrating to COBOL version 6. It'll help you make sure your code is up to snuff before you migrate.
Okay, so now the reason that this is headed Release 2 base is because some of these items were actually in version 6.2. I don't know how many people were on our zED talk when we spoke about 6.2, so this gives a bit of a review for you. The notion of a defines a compiler of conditional compilation is that you can now have, the same way that you have conditional assembly, the same way you have conditional compilation in PL1, you now have conditional compilation in COBOL, which lets you combine different options within the same program. So for example, you have a defined is CICS with a value. Then you define that as a parameter. Now what happens is, if I pass that parameter to at the time of compilation, it will pick up the CICS statements. If I say this is not a CICS program, then it will not pick up the CICS statements at all. It will pick up the non-CICS. In this case, the language of the CEHDLR is a language environment handler. The advantage here is that if you have the same logic for example, a batch program and a KICS program, and the only difference is that the batch frame is doing batch file I/O, and the KICS program is invoked through CICS and is executing KICS statements, you can have the same logic and just have the conditional compilation controlling the I/O. So if you have to change the logic, you only have to change it in one place. You don't have to go around and say, oh yeah, I changed it there, then I change it in the second place also. This lets you have, in terms of organizing your logic, a more elegant and, in my opinion, a more streamlined way of doing this. Ed?
Okay, so here's how you might use the init check option to have the compiler check for uninitialized data items and issue warning messages when they're used without being initialized. So you can see here the compiler option in the top statement. The init check is used. And then as it goes down here and does the compute, if you use that, you've got assurance that you've got some good data so you don't ab in or get issued a warning.
Okay, wait a minute, Ed, go back just a minute to there. There's something to point out.
Okay.
Go back to the previous foil just for a moment.
There you are.
Okay, if you'll note now, one of the new features of COBOL is that you can do a comment by doing an asterisk and a greater than sign. So that compute R is not active right now. It's a comment. So if R equals 0, and I have not given R a value, if you notice in the data division, it just says R pick 9.2, but it has no value. And if that compute R statement is commented out, then when I do if R equals 0, what value is R going to have? I don't know. Ed doesn't know either.
Right.
Neither of us knows. And I don't think anybody who's listening to this session will know either. Okay, unless somebody has great telepathy, or gets or is able to transmit themselves into the circuitry of the mainframe.
Whatever was there.
Right. So now go to the next foil. So now what happens is now you get a warning. You say the data tomorrow may be using this thing before it's set, because that's what's happening. If you have the init check set, it gives you that warning as a compiler. It's telling you, hey, you're doing this before you set anything. Pay attention. Is this what you want to do? Now, sometimes it doesn't matter. Sometimes you're using something before it's set, but you're going to set it yourself. But here you're using it and you haven't set it. And so that's why it gives you the warning. Ed?
Yep. Okay, so we mentioned the inline and no inline just briefly, the compiler directives. And these are used to control growth of the programs due to copying procedures in line. That is within the COBOL program. So eliminating an error handling case might be a good use case here. So it keeps your program from growing and growing and growing, and you can use inline, or you can say no inline to help you control those instances.
Now, another example is SS range. SS range actually is something that people should be familiar with, going all the way back to at least COBOL 4, I think goes back earlier. What was SS range used for? SS range was used when you were processing and you exceeded a table, and normally if you'd exceed a table, the program would keep on running until it actually came to where the data had been overwritten and blow up, which would usually be an extremely messy experience. So now, so if you put in SS range, it will immediately stop you as soon as you exceed a table. The problem is, or was, that originally the only option for SS range was to append. Now, if we had, I'm sure nobody in the audience codes like this, okay? Nobody should feel offended. But you have somebody who's not so careful in their coding, and they end up exceeding the table in 3 or 4 or 5 or 6 places. Well, the way SS range was set up, it would have been the first time that happened. So the developer would go in and fix that first one. Then they'd run it again, and it would have been the second time. And they have to go and fix it again. Then they go in and you get the idea that this was a very unpleasant way to have to debug something. The sub-option message says that if I exceed the table, don't append. Just give me a message that I exceeded the table. So in that case, what will happen is that every time the user exceeds the table, they'll get a message. So if you have our sloppy programmer exceeding the table in 4 or 5 places, assuming the program didn't append because the data was actually overwritten, so then what will happen is that you will then get all these messages, so this can all be fixed at the same time, rather than having to fix it stepwise after each event. In the case of test, the whole idea of separate and no separate was that when you have the test option, you generate a side file that has metadata. Now, this side file information could be combined with your actual load module or not, as the case may be. By specifying separate and no separate, you determine whether the metadata should be combined with the load module or kept separate as a separate file. In addition, the idea of using dwarf or no dwarf is because dwarf is a specific format for the metadata. IBM uses a dwarf format, but for people who are using brand X, in this case the example given was Expediter, generating dwarf doesn't help very much. So therefore IBM says, fine, we will let you say no dwarf, it will generate the metadata in a different format which brand X products can then use. Ed?
Okay, so in COBOL version 6.2, we introduced the JSON tar statement. And this is pretty cool because I can now convert JSON text to COBOL data format within the working storage of your program. So this statement really positions you to create web services and connect your external environments in a RESTful solution, which many people are doing today. So you could pass data from like a distributed environment into a COBOL program using this new JSON tars statement. And you can find more information and see an example video of that being used here in that link below. But that's pretty exciting new feature, and I hope you guys make use of that.
Okay, here's some additional resources for people to review and study. The product page, the documentation. This has been extensively updated. I would like to add that people should realize that in addition to the discussion forums, which are often monitored by members of the development group, in addition to that, the overall support for COBOL 6 has been greatly updated. IBM feels very important that people should feel comfortable with the COBOL 6 language, with the COBOL 6 compiler, and as a result, when cases are submitted, they are given a fairly high priority, and there's a lot of, what should I say, focus put on resolving them as expeditiously as possible. And if you feel that there are things that have not been covered by us, these resources give you additional, what should I say, additional place to look. Ed?
So we've come to the end of our presentation. I hope this has been helpful to you all to understand some of the new features and things you can take advantage of in the new versions of COBOL. COBOL's not going away. COBOL processes the majority of financials today. Billions of dollars are moved around the world every day with COBOL programs on the mainframe. And we've heard the debates and we've heard the debate. And the mainframe still has a very, very strong ROI. People are realizing that COBOL programmers are aging and retiring and moving away from the workforce. There's been a lot of effort around training new programmers for COBOL coming out of college, and there's a lot of exciting things going on out in the world. And if you're interested, there's also lots of forums like Z just pointed out, but get involved, help your schools, help your colleges, let people know how important COBOL is to your enterprise. And with that, we'll open it up for questions and answers. Thank you all for attending.
I would like to add one other point here. COBOL sometimes gets bad press. I know that there have been cases. I won't list the states where this happened, where people complained that their unemployment system was written in COBOL and was terrible. In a sense, the reason it was terrible was because it was never maintained. It just kept on running. In a sense, this is a testament to the fact that COBOL could keep on chugging along without anybody paying attention to it. Now, obviously, if things chug along and don't pay attention, don't be surprised if something breaks afterwards. This will be true for anything. And just imagine your car. It runs smoothly until you never change the oil. Hey, it runs fine, right? You don't even pay attention to the little idiot light. What's going to happen to your car? Not going to be in good shape. The point here is, if you take care of your COBOL, you take advantage of these features, you will find that this is competitive, better than competitive, with almost any other development environment when it comes to business-oriented processing. Do we have any questions?
Yeah, guys, looks like there's one question here. Can you talk a little bit about 64-bit?
Okay, 64-bit is being introduced. It's a little bit complicated to do. It really goes beyond the scope of what we're talking about right now. But it is being introduced. It will allow a lot of, what should I say? It will expand the space in which you can develop it. Okay, even going to 32-bit was a major expansion. Going to 64-bit is going to basically open up the universe. But as I said, it really goes beyond the scope here. It's something that cannot be answered in just a couple of minutes because there's a certain amount of work that you have to do in order to take advantage of the 64-bit capability.
Okay. And then the next question is there a JSON generate function?
I don't think, I would have to check. I don't think so, because this is, well, I shouldn't say that for sure, because I know that there was a lot of work done with the JSON. So, please take the email address, and we will get back to, we'll get back to you to confirm.
Okay.
Yeah, Z, keep me honest here, Z, but I don't know that there is in the COBOL language, but I think there's a feature in IBM Developer for Z Systems, IDZ, our development tool, where you can actually take a COBOL copybook and then generate some Java out of that. Is that correct, Z?
But as I said, I want to check and see in the language itself if you can do that.
Yeah, I don't know that it is in the language or not, so you're correct. We need to get back on that.
Okay, great. So we'll get back to you on that one, Keith. There's a couple other comments in the chat, but it doesn't look like the rest of the questions are handled. And we're at the end of our 45 minutes. So great job today, guys. Thanks for taking the time to present today. For anybody, if we didn't get to your questions, please either contact me, Ed, or myself, and we can address those after the presentation. As a reminder, I'll send out a recording of today's session as well as the presentation deck. And please feel free to fill out the survey after you close out your WebEx. So thanks again for tuning in. We look forward to our next zED talk in July, which will be on COBOL migration and when to use IBM's automatic binary optimizer. So we hope to see you then. Thanks, everybody.
Thank you, everybody. Thanks, Brian. Thanks, V.
Yes, thank you.